Hello everyone and welcome back to Serendipity in Quarantine. Today we are going to learn about the plate tectonic theory. So before watching this video, I will recommend you to watch the seafloor spreading as well as the continental drift theory video. And if you still haven't subscribed to this channel, then please do subscribe and don't forget to press the bell icon. So let's begin. So as we saw earlier, according to the continental drift theory by Alfred Wegener, he stated that there was a one solid form of continent called Pangaea, and over the period of time this Pangaea got split into various types of continents and it got transformed into the existing continental positions. So according to him, the continents drifted apart. But after that, various theories came along. For example, Harry Hess concept of seafloor spreading. So with help of this, scientists like Mackenzie, Parker and also Morgan independently connected the available ideas and came out with the another theory called the plate tectonic theory. So the tectonic plate is a lithospheric plate. It is a massive irregular shaped slab of solid rock and is generally composed of both continental as well as oceanic lithosphere. So continental lithosphere is on the continents and oceanic lithosphere is basically under the oceans. So the plates move horizontally over the asthenosphere as a rigid unit. So we have seen earlier that there are various types in the interior of the earth. So one of that is asthenosphere. So it is rigid and the lithosphere consists of crust, top mantle with thickness range varying about, for example, 5 to 100 kilometers in oceanic parts and 200 kilometers in continental areas. So here in this diagram we can see this Pacific plate is the oceanic plate while the Eurasian plate is the continental plate. So there are total 7 main types of plates and some of the minor plates. So these major plates are, first one, the Antarctic plate. It is surrounded by the oceanic plates. Then second one, North American plate. It consists of Western Atlantic and some part of the northern oceanic plate. Then third one is South American plate within the Western Atlantic floor spreading from North American plate along with Caribbean island. Then Pacific plate, India, Australia and New Zealand plate. Then African plate and the last one Eurasian plate. And some of the minor plates, for example, Cocos plate near Caribbean Sea in Central America, then Nazca plate between South America and Pacific plate, and recently there have been discovery of a new plate between Cocos plate and Nazca plate called Malpelo plate. Then there is Arabian plate which consists of Saudi Arabian landmass, Philippines plate, Scotia plate, Caroline plate, etc. So these plates have been constantly moving over the globe and it has been observed that it was not the continent that was moving as stated by Alfred Wegener, but actually the plates were moving and along with this plate the continent kept moving. So this process has been observed in geological past as well as it continues to move in future as well. So all the plates are still moving to this date. So Pangaea, for one example, was the result of converging of the different continental masses that were the part of one another plate. So scientists use paleomagnetic data and they determined position held by each of the present continental mass. So we will see in detail the position of Indian peninsular mass over the period of time. But before that, let us study various types of boundaries, so which were around the each and every type of the plate. For example, in here we can see these plates are surrounded by convergent boundary at the corner of the continental plates, and in oceanic plates there are some divergent boundaries. So we will see now what are these boundaries. So divergent boundary is a type of boundary in which new crust is generated as plates pull away from each other, and the sides where this plate move away is known as the spreading side. For the best known example is mid-Atlantic ridge, which is generated due to the moving away of American plate and Eurasian African plate. Then there is convergent boundary. Here the crust is destroyed as one plate dived on another. So there is cause of subduction of any of the plate. Usually the oceanic plate, if there is a collision between oceanic and continental plate, but there can be other types of convergent boundaries, for example between two oceanic plates or between continental plates. And then the last one is the transform boundary. Here the crust is neither produced nor destroyed, but the plates slide horizontally past each other. So here in this diagram we can see that there was the convergent plate. We can see that there one plate is getting subducted, and here the subduction zone is there, which is causing formation of trench. Then at divergent plate boundary, plates are moving away from each other and creating new plate, and here in transform plate boundary they are just sliding over each other. Usually the position of these boundaries determine where the earthquakes and volcanoes will be present. For example, in this map we can see that along the convergent boundaries we can see the presence of deep earthquake zone as well as the volcanic eruptions and volcanic hotspots. So the convergent boundary causes collision of two plates, and as we know that these plates are still moving, hence it can be one of the cause of volcanic as well as earthquake. And along the divergent boundary you can see shallow earthquake centers. So these were the information about plates. Now we will be seeing the what was the rate of the movement of these plates as well as the position and what force is required to move these plates. For example, the rates of the each and every plate is different from one another. For example, Arctic ridges has the slowest rate, which is less than 2.5 centimeters per year, but the Eastern Pacific rise near Eastern Island in Southern Pacific, Chile, has the fastest rate of more than 15 centimeter per year. So which force does drive this plate movement? So earlier it was considered that Earth is a solid motionless body. However, the concept of seafloor spreading and unified theory of plate tectonic emphasize on both surface of the earth and interior, which is not static and motionless, in fact it is moving. So the heat energy is causing the movement of this plate. For example, the heated material rises to the surface and it spreads and begins to cool and then sinks back into deeper depths. So this cycle is repeated and it is known as the convection cell or the convection flow. So the heat within the earth comes from two main sources, that is radioactive decay and the residual heat. So these two types of sources causes convection cells, which helps in movement of the plates. And also the Harry Hess's theory of seafloor spreading provided evidence of this movement of the plates. Then now we will see how the Indian plate moved. So Indian peninsular plate and Australian plate continental portion were joined before. So after the subduction zone along the Eurasian plate, the Himalayas were formed on the northern plate boundary. So the continental convergence was over here, and also it passes from Himalayas to the Rakhine mountains in the Myanmar, and it also extends towards the Java Trench in the Indonesia. And then in the west it is still the Kirthar mountains in Pakistan, while spreading it to the Red Sea, and this is called a spreading side from the Red Sea rift southwest along with the Chagos archipelago in the Indian Ocean. So it is along the divergent boundary. So India was a large island situated off the Australian coast, and in the vast ocean the Tethys Sea spread it from the Asian continent till about 22 million years ago. So here in the above map, if we imagine, so India was here near Australia, and here was the Tethys Sea. So the Indian island was a large island, and it moved northward towards the Eurasian plate. So while doing that, it consumed the Tethys Sea. So these two major plates were separated by it, and while colliding in the convergent boundary, it created the subduction zone, which made the most fertile land of the northern plains. So the major event that occurred was outpouring of lava and formation of Deccan tracts during the formation of Indian plate toward the Asiatic plate. So about 40 million years ago, after that the formation of Himalayas took place. So scientists believe that the process is still continuing and height of Himalayas is still rising even to this date. So this was the end of this video. If you like this video, please like, share and subscribe to this channel, and don't forget to press the bell icon. Thank you for watching.